Linearity, uniqueness, and ownership. 3 ideas that are rapidly taking hold in modern programming languages, and all based on concepts from substructural logic. But how are they similar? How are they different? Can we unify them and get all the benefits at once? Let's find out. First of all, what do we mean by substructural? Put simply, although some data can be used however we like, this isn't always the case. We can't always copy things as many times as we want, throw them away whenever we like, or make changes while someone else is using them. One way to understand the idea of data as a resource is through linear types, which are like cakes. Delicious. You can only eat them once, and then they're gone. But you have to eat them, or your friend who baked them for you will be very disappointed. Here's an example in Haskell. Notice the lollipop-shaped arrow, which means that we have to use the cake linearly. This fails to type check. We can't have our cake and eat it too. On the other hand, unique types are more like coffee. If we pour a cup of coffee, then it's fresh, but only until someone drinks it. Here's an example in clean, where the star prefix means that a value is unique. This doesn't type check either. Telling someone their coffee is fresh when we've just had a sip isn't a very nice thing to do. It turns out that the literature gives a fairly mixed picture of the relationship between these concepts, but our takeaway is this. Uniqueness means that a value has never been duplicated, while linearity means that a value will never be duplicated. This key insight allows us to contribute a unified system, which allows for both linear and unique types. The calculus is based on linear logic, but with an added star modality over which the nonlinear bang acts as a relative monad. We can forget a uniqueness guarantee or impose a linearity restriction at any time, but we can't go back in the other direction. We also contribute an implementation of the calculus using Granule's graded modal types. Granule can already represent co-effects and effects, but we add a third flavour of modality, called guarantees, for things that behave like uniqueness. Here's an example with all 3 flavours. This one does type check, since we no longer pretend that a value is unique after it has been duplicated. Having unique types means that we can implement mutable arrays, allowing us to demonstrate some performance benefits. Mutability means that overall runtime is reduced, and you can see from the graphs that this is thanks to spending significantly less time on garbage collection. So how does ownership fit in? Well, languages like Granule and Idris have graded types, which offer more precise restrictions than linearity. Similarly, we can split up a uniqueness guarantee into fractions that can be put back together again later. This work is ongoing, but we hope that this will be a way to understand Rust's more fine-grained memory management and the ideas behind borrowing. Feel free to come and find me at the poster session if you want to chat about this work. And here are some references where you can read more deeply about Granule and the ideas behind linearity, uniqueness, and ownership. Thanks so much for watching. See you soon.